However, the real world is not so perfect. At least most of the times it's not. And one thing that can happen is that the duration of tasks is not fixed as we assumed in the optimization model. So there might be some variability and we might spend a larger or a smaller time for performing the very same tasks with different amplifiers. Second, we assumed implicitly in our optimization model that the room we had to store amplifiers in between every two stations was infinite. And that might not be the case. And if that capacity is not infinite, or in particular, if there's no capacity at all, we might have stations blocked or stations starving due to that fact. Third, sometimes we might need to reprocess parts. Again, we might have to reprocess or to reassemble parts because things went wrong or because there were some faults during the assembling process, and we need to send back that amplifier to start all over again, or to reprocess or to reperform some tasks. We might have breakdowns, which is something that pretty often occurs, or you cannot forget about that, because at some point machines will break and you'll have to spend some time to repair them. And finally, we assume that raw materials are always available, which might not be the case because our suppliers might have some delays, or because the quality of the material delivered is not good enough and we stop our production line. In our assumptions, in our model, we're going to introduce these three elements of these five to introduce some features that the real world might have. So in this case, Chyp does have task duration which are variable, buffers are not infinite, and sometimes you have to reprocess parts. So we're going to see in detail how we're going to which are the hypotheses or the assumptions regarding these three elements, and then we will see how we represent that in our simulation model.